Okay, let's have some review in IB Math Remainder Theorem. First is fundamental theorem of algebra. If p of x is a polynomial degree n, then has n roots, and remember you had to count all those double roots. For example, so let's say you have a x minus 1 is a double root. That means x minus 1 times x minus 1, that is x minus 1 whole quantity squared. You count that one as two roots, don't count just one. Similarly, if you have a triple root, you have to count them too. So that's what it means. So if you have a polynomial n degree, it has n roots, including all the double, triple, all of that. So here's another thing, complex conjugate theorem. Alright, so we don't prove it here. You will prove this stuff when you go to college, or you're doing your master's or PhD. You're specializing in algebra, group theory, ring theory. You will understand why, but here it's going to be you're observing, you will say, okay, so you don't prove. So here's the thing. So if you have a polynomial with a real coefficient, then a plus b is a solution, then a minus bi also a solution. So that means, what is the a plus bi? Is a complex root. Then you have the conjugate a minus bi. So for example, 2 plus 3i is a root, then 2 minus 3i is also a root. So let's go to this rational like irrational, this thing. So for example, if a plus square root of b is a root, then a minus square root of b also a root, if a polynomial with rational coefficient. Okay, the next one, p is a polynomial odd degree, real coefficient, then the equation has at least one real solution if it is odd. You know why? The complex roots comes in pairs, they cannot come alone. So if you have there's one guy, the real guy, he's going to be alone. So complex guys, they come in pairs, you cannot separate them. Alright, so that's the reason. So I'm going to go back and I'm going to do some problem. Okay, so here you go. If p of x is a cubic polynomial with p of 1 is equal to p of 2 plus i equal to 0, that basically means x minus 1 is a root, x minus parenthesis 2 plus I is a root, and they give a p of 0 is negative 20. So they ask you to find p of x in expanded form. So I make this chart, divider, remainder. So the divider is x minus 1. When you divide, p of 1, that means x minus 1. The remainder is 0. X minus 2 plus I, the remainder is 0. So what are you going to do is, so x minus 1 is a factor, and x minus parenthesis 2 plus I is a factor, so does its conjugate. So that is, okay, I say it right, but I don't write right. Okay, so does its conjugate. So, okay, I'll come back here. So, x minus parenthesis 2 minus I, 2 plus I, the conjugate 2 minus I. So, your polynomial should be, remember, there should be a real number multiple time x minus 1, x minus 2 plus I, x minus parenthesis 2 minus I. So, this is the. So what you do is you just simplify. So this one complex. So what you do when you multiply this, use FOIL. So x squared, and the easy way is negative 2, negative 4x. There are shortcut, yeah. So this is the complex number multiplied by conjugate. I already have a formula. A plus ib times a minus ib is. You just do the FOIL. You will get a formula a squared plus b squared. In general, z times z conjugate is equal to absolute value of modulus squared. That's same as a squared plus b squared. You should remember this formula, and it's very handy. You don't want to waste time just doing FOIL. FOIL is over. So you're not going to take your fingers and count numbers. So those days are over. So here, what x squared minus 4x. So here got 2 squared, and the number sitting in front of I is what, 1. So 2 squared plus 1 squared. That's it. And you simplify. So now what you do is, they gave you p of 0 is negative 20. So you plug in x equal to 0 here. You get negative 20 equal to, you plug in 0 for x, that is 0 minus 1, 0, 0, that's plus 5. So what you get is a times negative 1 times 5, that's negative 5a equal to 20. So you solve for a equal to 4. So therefore the polynomial is 4 times this thing, and that's the answer. Okay, I'm going to go to the next one. Alright, so here's the problem. Px has remainder 2 when divided by x minus 3. So I put in the chart. So when you divide by x minus 3, remainder is 2. When divided by x plus 2, remainder is negative 13. So the question is, find the remainder when p of x is divided by x squared minus x minus 6. So x squared minus x minus 6, you wonder what is that x squared minus x minus 6? You know how to factor. This is nothing but x minus 3 times x plus 2. So what we do is, actually I skipped my step. So you're going to come here. So we use remainder theorem. So what I do is p of x equal to x minus 3 x plus 2 times t of x, sum t is a function in x. And here, this is the one you need to understand. Why I put ax plus b? Usually you always put some real number. Why I put ax plus b? When you divide a polynomial by a x minus 3 x plus 2, so that means but degree 2, quadratic. When you divide by quadratic, this is the remainder is going to be linear, that is ax plus b. A could be 0, that's okay, but in general ax plus b. So this is the thing you have to remember. I mean, rest of them is very easy using fundamental theorem, algebra. So this is the only step you need to remember. So if you have a cubic, something comes here, x minus 3 x plus 2 something, and here you're going to put a quadratic. You got it? So this is the key point. So what you do is, now you plug in x equal to 3. When you plug in x equal to 3, p of 3 equal to, you just plug it in here. Alright, 3, that's going to be 0, and here you put what, 3a plus b, that should be equal to 2 is given. Then plug in x equal to negative 2, p of negative 2, 0, so that's going to be, so you go back here, so this is going to be 0, negative 2, so that negative 2a plus b equal to negative 13. So you got one equation here, another equation here. All you had to do is you had to solve these two equations. Alright, so you know you have two equations, two unknown, you know how to solve. And I show you a step here, you know, but I just leave it to you, you know how to solve. I don't want to waste my time in solving a simple, you know, algebra problem. Alright, so linear. So what you do, so what you find is, okay, a equal to 3 and I found b equal to negative 7. So the answer is ax plus b, that's a remainder. It is 3 times x minus 7. Okay, you got it. I'm going to go to the next problem. So this problem is a bit different. Find all quadratic polynomial with real rational coefficient having 2 minus I square root of 3 and square root of 2 plus 1 as 2 of the roots. Okay, so it's a quadratic, that means degree 4. So you know that degree 4. And there are two types here, you know. I mean, like, I don't know. One is like a quadratic form type. Other one is like a squared minus b squared type, you know. Something like x squared minus 4. So it could be like x to the 4 minus something like a 4 something. Okay, x to the 4 minus 4. And anyway, I'm going to skip for the time being. So you know what I'm talking about. So that's also another type, you know. And there may be a problem. You may have to use the tactics. Okay, the technique. Alright, I'm going to go back here. So I'm going to use the fundamental theorem of algebra. 2 minus I squared of 3. The conjugate 2 plus I squared of 3. then you have 1 plus, remember you are writing the form a plus the radical, that's square root of 2, a rational number. 1 plus square root of 2, 1 minus square root of 2. Therefore, so in the simplest form, I call simplest form because it could be any multiple of this one by a real number, but I just put it x minus this root, x minus the next one, x minus this guy, x minus this guy. So you multiply, first you multiply this by 4, so you get x squared, and negative 2, you get 4x. And when you multiply two complex numbers, it's the easiest way is, so it's going to be 2 squared plus square root of 3 squared. I show you a formula earlier. Z times Z conjugate is absolute value Z squared. So 2 squared plus square root of 3 squared. That's it. And over here, x squared minus 1, so minus 2x. And over here, 1 squared, this a plus b, a plus b times a minus b, so it's negative time. Okay, so this negative become positive, so you get what? 1 squared minus square root of whole count squared. So that's, so when you simplify, x squared minus 4x plus 7, x squared minus 2x minus 1. So collect the like terms, so you end up having this one. Alright, so this is the simplest form, but it could be anything like 8 times a is a real number or rational number, whatever. Real number, I don't know, I think it's a rational real number, I don't know, I had to look at the problem, what they're saying. Real rational, it could be a real number, I don't think rational number. Let me take this one out. Real rational, okay, it could be a rational real number, doesn't have to be. Alright, real number, let me change this one, I don't know why I make this mistake. Alright, I'm gonna erase this one. It's a real number. Alright, so 2 times that one. So that's all I have for you today.